All right, so now we're going to uh, learn how to make regressions in R. I'm using the same data that we did before, but I've filled in the data points that we didn't have with the average of each value. So this is making a very dangerous assumption that when we didn't have a data point, that country um, was just average on that uh, variable. Um, so if I was actually trying to predict data or life expectancy, I probably wouldn't make this assumption because it's a really uh, big assumption. However, since we need data just to look at what regressions do, I've filled in the data. And regressions are more sensitive to missing data than correlations. It's harder to ignore the missing data. All right, so let's download this file. All right, and it's gonna be country with averages um, with not available. So we've added all of the averages to this data. Okay, I'm gonna save it on my desktop. All right, now let's go into R. And we're going to, I'm just gonna, since we just made a read CSV just recently, I'm just gonna scroll up with my arrow keys and then create another data set or variable. Let's call this reg for regression, right? Gonna enter in the regression data that we need. Okay, open, right? Just to make sure that our data is in there, we're gonna look at reg, and sure enough, all of that data was imported to R. All right. And now we're going to use a function called LM for linear model, and we're going to see life expectancy be predicted, so that's the little tilde, by money, happiness, ecological footprint, murder, math scores, reading scores. And we're getting our data from the data we just inputted in reg. All right, and we're actually going to put this process data into a variable fit. All right, and then we want to make a summary of fit. Okay, so it did a regression analysis for us. So for each one of our predictors, we have an analysis of whether it was significant. So can one thing predict the other thing? So for money, we have a t-value for that prediction, and here we have 2.12 e to the negative 10th. So that's very, very small number, and it's very significant. So yes, money can help us predict life expectancy. Can it help us predict happiness? Well, yes, but not to the same extent as money. Can it help us predict our ecological footprint? There's only a 7% chance. So it probably can, but we don't have a statistically significant effect there. Can murder rates help us predict life expectancy? Yes, very much so. That's a very low p-value, which means that that relationship is significant. Can math scores help us predict life expectancy? Not really. There's a 30% chance that they can't. Can reading scores help us predict? Yes, reading scores can. All right. And then, all right, so r squared is another interesting value. R squared means if you take all of these predictors together, what percent of life expectancy can we explain with all of these predictors? So we can explain 60% of the differences in life expectancy with all of our predictors that we put in. So there's still other things that affect life expectancy that we don't have, and we don't know. Does this model predict? Yes, that's what this p-value is showing.